Question number 4. Inside a liquid, options are given below. A. The pressure decreases as the depth measured from the free surface of the liquid increases. B. The pressure is the same at 1 meter inside the liquid regardless of the nature of the liquid. C. At 1 meter inside the liquid, the pressure is the same in any direction. D. At 1 meter inside the liquid, the pressure is the same regardless of the temperature of the liquid. E. The pressure can be measured with a dynamometer. Let us interpret every option one by one from the next slides. Option number A. Look at that formula. P is the pressure equals to rho GH, where rho equals to density of the fluid, G is equals to acceleration due to gravity, and H equals to height of the fluid. Here height we can also relate it with the depth, and it represents with D. Pressure is directly proportional to the depth according to formula, and if pressure decreases, depth also decreases, or vice versa. So pressure decreases, depth increases. It is the inverse relation in the statement that is wrong, and you can also check it from the picture that where the height is high, depth is more, the pressure is increasing. Otherwise it is opposite to that. So option number 4A is incorrect. Moving on, option number B. The pressure is the same at 1 meter inside the liquid regardless of the nature of the liquid. According to that formula, we are using the previous one, rho GH. Here density equals to mass over volume, and density is directly proportional to the mass. According to that graph, look at that the temperature and the pressure of the different liquids, and their graphs are very different from each other. So it means that pressure is the same regardless of the nature of the liquid, but here the liquid's affection is different whenever the temperature and pressure we will measure. So this option is incorrect. Option number C. At 1 meter inside the liquid, the pressure is the same in any direction. Pressure in liquids and gases. The pressure in a liquid or a gas at a particular point is equally in all directions. At the same depth in the liquid, the pressure is the same in all directions according to that. So this option is correct. Option number D. At 1 meter inside the liquid, the pressure is the same regardless of the temperature of the liquid. So according to the graph, temperature and pressure both are directly proportional. So pressure is directly proportional to temperature. If pressure increases, temperature increases, and vice versa in the next line. So pressure is the same regardless of the temperature. It is written in the statement, which is incorrect. Option number E. The pressure can be measured with a dynamometer. Here is a picture of the dynamometer, and a dynamometer, also known as dyno, is a device that measures force, torque, or power. So this option is also incorrect. Here the correct option is option number C. Moving on, question number 5. What are the correct coefficients reading from left to right when the chemical equation Ki plus KOH plus Cl2 it will gives you KiO4 plus KCl plus H2 is balanced. So options are given below with different types of coefficients, and whenever we are going to solve this equation, we have to balance this equation. And how to do that? The equation is written here: Ki plus KOH plus Cl2 KiO4 plus KCl plus 4H2O. Moving backslide, and we will check the other whether we are using the options method or we are just solving that. We are actually solving the equations on our own. So 4 is written with H2O water. In the next, K plus 8 KOH. In the next equation, K is going to be 8. KCl is going to be 8 with having 8 coefficient, And the next one, chlorine with 4 coefficient. So 184, 184 both are equal on this slide. So in this method we are using it to balance here this equation are on. But there is also another method, and which is there to put every option and calculate the total number of the coefficients on both sides. This is your own choice which method you want to use. I am using the balance the equation directly. So according to that, option number B is correct. Moving on, question number 6. A projectile is launched from the ground at a certain angle. Which of the following statements is true when air resistance is neglected? Options are A. Its horizontal acceleration is 10 meters per second. B. Its vertical acceleration decreases during the flight. C. Its vertical velocity is constant. D. The maximum vertical displacement is called the range of the projectile. E. The angle relative to the ground is the same on the way up as on the way down. So we are going to analyze every option one by one. Option number A, its horizontal acceleration is 10 meters per second. There are no horizontal forces acting upon projectiles and thus no horizontal acceleration. So this option is incorrect. B, its vertical acceleration decreases during the flight. There is a vertical acceleration caused by gravity. Its value is 9.8 meters per second scaled down. The vertical velocity of the projectile changes by 9.8 meters per second each second. So this option is also incorrect. Option number C, its vertical velocity is constant. The vertical velocity of a projectile changes by 9.8 meters per second each second. So this velocity is changing, and this option is incorrect. Option number D, the maximum vertical displacement is called the range of the projectile. The range of the projectile is the horizontal distance the projectile travels from the time it is launched to the time it comes back down to the same height at which it is launched. So this is the range. It is actually the horizontal displacement, not the vertical displacement. This option is also incorrect. Option number E, the angle relative to the ground is the same on the way up as on the way down. When a projectile is launched, assuming that air resistance is negligible, the constant is the projectile's initial velocity and the angle at which it is launched. So this option is correct, option number E. So here, question number 6 answer is option number E. Question number 7. Which one of the following is a chemical phenomena? Options are given below. A, the expansion of railway line. The electrostatic charging of particles. C, the burning of wood. D, the melting of sugar. E, the dissolving of sugar. So option A, the expansion of railway line. The railway tracks undergo expansion in summer and contraction in water, so it is a reversible physical change. So this option is incorrect. B, the electrostatic charging of particles. Electric charge is a physical property of matter that causes matter to experience a force when placed in an electromagnetic field. So this option is also incorrect. The burning of wood. The burning of wood is a chemical change as it leads to the formation of new substances like carbon dioxide, gas, water vapor, ash, etc. So this option is correct because it is a chemical change. Option number D, the melting of sugar. Melting of sugar is a physical change. Sugar starts melting at around 140 degrees centigrade and after that start to decompose into a brown substance. This browning of sugar is also called caramelization. If further heated, it starts to turn black and gives off fumes as the sugar decomposes down to carbon while hydrogen and oxygen evaporates its organic fragments. At this point the change becomes chemical, but here the first change is physical, so this option is incorrect. E, the dissolving of sugar. Dissolving sugar in water is a physical change because sugar molecules are dispersed but the individual sugar molecules are unchanged or do not undergo any chemical change. Moreover, this sugar can be obtained back by evaporation of water and the water by condensation of water vapor, so this option is incorrect. Here, the correct option is option number C. The burning of wood is a chemical phenomena. Question number 8. When light passes from a medium with a low refractive index to one with a high refractive index, then the options are given below. The speed of the light remains the same and the ray has the same direction. B. The speed of the light increases and the ray bends towards the normal. C. The speed of the light decreases and the ray bends towards the normal line. D. The speed of the light remains the same and the ray bends towards the normal line. E. The speed of the light remains the same and the ray bends away from the normal line. Since V equals to C over mu, the velocity of the wave is lesser in the medium with high refractive index. Velocity is directly proportional to, or it is actually inversely proportional to, refractive index mu. So when refractive index increases, velocity must be decreases. So inverse relation. Here we can also check the ray of light when it enters into a medium, different kind of medium. So the ray bended towards the normal line. So you can actually check it, the ray which is bended towards the normal line. So according to that, option number C, the speed of the light decreases and the ray bended towards the normal line, is the correct option. Question number 9. Which of the substances in the following reaction exist in the gaseous phase under normal conditions? Reaction is given: calcium carbonate plus 2 coefficients of hydrochloric acid. Calcium will get you calcium chloride plus water plus carbon dioxide. Options are given below: calcium carbonate and calcium chloride. B. Calcium carbonate and water. C. Calcium chloride and HCl. D. Water and carbon dioxide. E. HCl and carbon dioxide. So calcium carbonate state is solid. HCl is actually the fuming one, concentrated. Calcium chloride is also the solid. Carbon dioxide is gaseous form and H2O is water. So here carbon dioxide is what? In gaseous form and HCl in a fumes. So the correct option is that carbon dioxide and HCl, option number E. HCl and carbon dioxide is the correct option. Moving on, question number 10. Two bodies that move in the same direction collide in a perfectly elastic collision. If the two bodies have equal masses, find which of the following statement is true after this collision. Options are given below. Their velocities will be equal. The two bodies will stop after collision. C. Their velocities will have equal magnitudes and opposite directions. D. One body will stop and the other will double its speed. E. The two bodies interchange their velocities. Conversion of momentum formula we are going to use here. m1v1 equals to m2v2. mv1 equals to mv2, equal masses. m1 equals to m2 equals to m. is cancelled. v1 equals to v2, interchange of velocities occur. And remember, their velocities are not same, so they move in opposite direction by interchanging their velocities. So according to that, option number E is correct. The two bodies interchange their velocities.